Hello everyone, welcome to today's session. My name is Wycliffe, and in today's tutorial, I want to share with you how you can interact with Google Earth Engine through three different languages or programming languages. One, we will start with the JavaScript, and then we look at how you can do the same task in Python and how you can achieve it with R, so that it doesn't matter the language you are using, you can still do analysis in the programming language of your choice. You don't have to know JavaScript, you don't have to know Python, you don't have to know R. But if you know one of them, then you can easily interact with Google Earth Engine to run your analysis or the analysis of your choice. Okay, let's get started with JavaScript. So in the coding environment here, we will easily interact with JavaScript because it's the native language um, for Google Earth Engine, right? So we'll set a base map of satellite so that we interact with it's always easier for me to see the background and to identify regions using the satellite background. If you prefer, you can add labels on the satellite so that you see the names of places. So this region is called Kericho. Okay, so what we want is the elevation data. So I will use SRTM and then copy the snippet here and add it to our coding environment. Because we are working in JavaScript, it is important to add this semicolon at the end of your code. But any variable you are setting, you need to start it with a var as a keyword, and then we can paste the snippet we copied. And then again, we end the code with a semicolon. So that brings our elevation data. The next data we want is the global administrative boundaries. So level 2. This is level 2 data. It's written level 2. So we copy the snippet and also bring it here with a var. And then we say global administrative layers. And then we paste the snippet and end with a semicolon, right? Then from this feature collection, we want to get a small region within Kericho. So we can put a marker here and then filter bounds of this, or if we really don't know the name. But if we know the name of our region of interest and we know it exists in the Gaul, then we can say Kericho and then var Kericho, remember var, and then Gaul, and then we filter. How do we filter? Using Earth Engine filter, where the name is equal to what we want to provide. So admin2 name is equivalent to Kericho. So that one will pick Kericho as a feature collection from this feature collection, or just one element Kericho. Okay. Or if you prefer, you can print Kericho just to confirm the same. This one is a typo, so Gaul feature collection. And then we see that it's one feature and the properties, the features, it's a feature with these properties. And the admin2 name is Kericho, right? Okay, after getting the region of our region of interest, we can center our map around that. So map center object, and then we say center object around Kericho and zoom it at a level of about 9, right? Then we add semicolon, okay? We can also add the layer of Kericho. And then we don't provide any visualization, and then we just call it our region of interest, okay? So you can see Kericho boundary drawn. All right, then we can also add our elevation data on top of this map and visualize it. So to do that, we call map, and then we just say add layer, and the layer we are adding is elevation, but not for the whole world. So we clip it to the region of interest, which is Kericho, and then we want it to look nice, because if we just print it like this, it is a gray It's just a gray layer because the colors stretch from Mount Everest to the deepest part of Mariana Trench, or just the deepest terrestrial surface. So let us provide some visualization parameters to improve how quality or the quality of this image. So we say stretch the values from a minimum of say 1080 to a maximum of say 2800. Okay, then give it a color palette, right? Color it beautifully such that the values range from blue in the low altitude regions to green in the mid-low to yellow in the upper altitude and red to the highest. Then give it a name like Kericho elevation. Okay, so with that, we'll see a better visualization of our region of interest. So we have elevation data for Kericho. But then what kind of analysis can we do? If we go to the end, we end with a semicolon, and then we can get the mean elevation here, the mean altitude. So to get that, we can create a variable called statistics, and then we take our elev and we reduce region because it's just one region, Kericho. They are not regions. So to reduce region, I used Control and spacebar to give me all these arguments. We won't need most of them. We just need the first few. Okay, so for the reducer, we will use ee.reducer. And then the reducer we want to use is mean, because we want the mean elevation here. Around where? Around Kericho. And then at what scale? At a scale of 30 meters, right? So that is going to give us the start, and then we can print what the start is, right? So if you look at the console here, a dictionary is created, and in that dictionary, we have elevation with its value. So you can do analysis on within your region of interest in JavaScript. If you see this I, it means it tells you that there is a missing semicolon. And remember, you need to terminate all your code with semicolon. It won't throw an error, but it's just a good coding practice in JavaScript to end your code with semicolon. You can then save your script or share with your friends. All right, let's do the same in Python environment. So we'll use Google Colab. I've named my notebook as rgee Python. So here, the first difference is that we will start by importing libraries. So we didn't need to import anything when we were working in JavaScript via this Google Earth Engine coding environment, because all those libraries we need are pre-loaded, okay? So, but because now we are in a foreign language, which is Python to Google Earth Engine, we need to import libraries that can create connection with the JavaScript. Okay, so the first thing we do is to authenticate, because we need to bring to the attention of Google Colab whatever our credentials are in Google Earth Engine. Okay, then we initialize our project. So to the initialize, we need to provide a project name, and the project name we get from our name here. We go to project information and we copy it from cloud project, right? Then that's what we bring here. So if we run this, there will be, okay, normally there is a pop-up. We allow, and then continue until it get access. Okay, so after we've allowed Google Earth Engine to connect to our Colab in this Python environment, you can see we have not used any var, we've not used any semicolon, because now we are in Python environment where those are not necessary. So we can start by bringing in our elevation data. And the elevation data, again, we go back to Colab, and then we say SRTM, and we pick the one with 30-meter resolution and copy the snippet. Once we've copied the snippet, we come back to Google Earth Colab, Google Colab, and then we print elev. After that, we can also bring the global administrative units, the level 2. as you can see here. We copy the snippet again, and then once we come here, we say Gaul or global administrative layers level 2 is here. Then we can print it and we see it's a feature collection. All right. Once we have that, we can now pick our Kericho from inside this. So again, we don't need to do what? We don't need to create any var argument in Python. So we just start with the name Kericho, and then we say from Gaul filter. Actually, it is the same code we had here. So we can just copy this without the semicolon. So the Python up to this point, both Python and JavaScript speak the same language or structure. The code structure is basically the same. Okay, so that will give us a feature collection, which is for Kericho with one element and several columns, 13 columns. All right. So once we have our Kericho region, we can then initiate a map. Remember here, we didn't have to initiate a map, but here we must initiate a map because we don't have it by default. So it comes from gmap, and then we say map. And for the base map, we can provide a setlight, just the same way I set options in JavaScript, right? So we see this, but we want to center it around Kericho. So we can say center object around Kericho at a zoom level of say 10. And then we see the map. So you can see it's centered around Kericho. To this map, we can add Kericho layer. So we add layer, and then we say the layer is Kericho, no visualization, but we call it our region of interest. And then map again. We can now see Kericho boundary mapped clearly. Okay, so on top of that, we can add layer, and the layer we are adding now is the layer of elevation, but not for the whole world. So we say dot clip to Kericho. So it will be clipped just for Kericho region. And then we need to provide some visualization parameters. So we start with the minimum. The minimum value should be basically what we set here. So I can also just copy this, in fact, up to the name. We can copy that and bring it here. Exactly the same. So I need the curly bracket and then put the minimum in quotes, put the maximum in quotes, put palette in quotes, and then blue, blah, 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 up to this, up to red, and then Kericho elevation. After that, we call a map, right? That should run without any problem. So we see the same map we were seeing on this other side, but now we are doing it in Python. Super easy in Python. The only challenge we faced was to do the importation of necessary libraries and do the authentication. After that, once it's authenticated, the rest of the code runs smoothly, normally without any problem. Simple modifications like no var, no semicolons, but the rest are basically the same. Okay, so we did some reduction. We reduced region, and then we obtained statistics for this. So we can also do that here. We can say, let's say we want some stat about 11, and then we reduce region. In reducing region, we need reducer. So we use reducer dot mean. Okay, and then we reduce this around Kericho. That is the geometry at a scale of say 30. And then we can check the stat. Okay, stat is an object with elevation and it's 1982 meters. So the same value we obtained here, maybe 89, yeah. So exactly the same elevation value here. But now we have done everything in Google Colab, which is a Python under Python runtime. So you can check here the runtime we are using. We are using runtime type Python 3. Okay. So the third language we are going to do similar thing in is R. So I will switch to R. In R, we talk of libraries. We import libraries again. And if we don't have them, we need to install them. And the library which connects us to Google Earth Engine is called rgee. So if you don't have it installed in advance, then you need to install it. Once you've installed it, you can just say library rgee, and then you will have your Python library, not really Python, but Google Earth Engine library loaded. Once it is loaded, if you are doing this for the first time, you need to clean the Python environment using this code here. So that ensures that you are working in a clean Python environment. Actually, I was not supposed to run it because my Python environment is well set. And then another code which you may need to run, because maybe not many people are using Python or Google Earth Engine in Python. In R, you need to clean or create a new R Python environment. So you can call it rgee environment or something, and then you run that. I will not run it because I already have it, but maybe I will have to run it because I cleaned my Python environment, but let's see. Okay, then we may need to do an upgrade, install upgrade. If you want to improve, if you want to get a new version or update packages, then you need to provide to upgrade your Earth Engine environment, right? So again, I will not run that for now. Then after that, we may need to tell Python, tell at rgee where to get which environment to use. So we use install set py environment. So that will tell Python or rgee where to get Python, where to get credentials to use with the rgee. Okay, so py environment is rgee environment, right? Something like that. Then we close this. Normally it asks you to restart, to do something like that. Then you should follow those. Then the next one is to authenticate. And in authenticate, you provide your username, and you also provide set Earth Engine to true and drive to true. So your user, for example, my user is this. Yours will be different from mine. And then the Earth Engine, you just set that to true. And also drive, you set to true. Okay, so once you set all this, you run this, it will tell you to allow Google Earth Engine to access your credentials. It will ask you to allow R Studio to access your Google Earth Engine credentials as well as tidyverse. Okay, so once that is set up, we can comment that out for now. Okay, and also that. Okay, and then for me, I will just go straight to initialization. So I will initialize a user. So we provide the username, which is my name, my username for this. And then we also provide the project. The project ID for this is EE dash the same name. And then we run this. should run without any problem. Because I cleaned this, probably it might bring problem. Let me see. Hopefully no. So if it bring problem, then it means I will have to reinstall. Yeah, because I cleaned this, I need to generate token, which is a good thing to see. And then we set my name there, and then we continue. This is a good thing to see so that when you face it, you see how to go about it. And then you pick this authorization code, and then you go back to here and you enter that code, and then it should be set successfully and everything is set now. All right. So once everything is set, we can proceed with the coding, getting the Gaul data, getting the SRTM data. I mean, this is if you really love R and you don't want to use either Python or you don't want also to use um, JavaScript. So here you can look for data sets by using $, image $, dataset, and then you also add $. So here is a list of all images that are available in Google Earth Engine, natively in the Google Earth Engine data catalog. So all of them you can see here and you pick the one you want. So for us, we want SRTM, this one, and we will feed it to a val object. So again, in R, we don't have var, we don't have semicolon. We just call them with the $ like this. Alternatively, you can put these ones in brackets and then provide the object ID, which you can get from here. If you go to SRTM and then you go to elevation, you can get the ID here. You can still use this directly. Control C, close, and then we go to R and set it there. You will still see a val as an image, Google Earth Engine image. For now, I just wanted to show you this with the data set so that you know how you can get all image data sets you want. If it is image collection, you just change this image to image collection. If it is a feature, you change that to feature collection, as you will see later. So here we want SRTM. If it doesn't show, then you just go back a bit and then bring it back again, SRTM, and then it pops up. Okay. So that's our elevation. Sorry, that's a typo. Elev, like that. Then we, of course, when we print it, it just show that this is an Earth Engine object, which is an image. Okay. Then after that, we can bring our global administrative layers second level. So that is now a feature collection. So EE and then feature collection and then data set, right? Data set. And which data set are we looking for? Global administrative layers level 2. Okay, then we fit that into Gaul. Again, this one you can also put just bracket and get the ID and put inside the quotation marks, right? So once you have a Gaul, if you print Gaul, it will be a feature collection at engine feature collection object, right? So that confirms that everything went well. If the ID is wrong, if you provided a wrong ID here, then it will not show, it will throw you an error. Okay, so if you want to get information about this Gaul, you don't worry, you just say Gaul and then the pipe operator, that is the percent greater than percent, something like that. And then EE underscore utils underscore dataset display, like that. And then it opens this platform where you can read more about the dataset. Okay, not the aim of today. Our aim was to get a region of interest, which is Kericho. So again, we say Kericho, and then we say from Gaul, $, filter, filter. Actually, let me bring what we had in Python so that you see the differences better. This one, copy, then we take it to R. Okay, so Gaul dot filter. So now that dot, we change it to $sign, right? And then EE dot, we change it to $sign. And then filter equal dot, we change that to $sign. So we just changed everything to $, right? And then we have our Kericho. So again, you run this, and then you run Kericho. Kericho is a feature collection, of course, but we know it is just one feature from this collection. So the replacement, the differences here is the $sign. Instead of dot dot, we use a $sign. Okay, so let's go to the maybe more interesting part. We center our object around Kericho, and then we set a zoom level of maybe 10. And here, the beauty of working in R, probably the beauty, is that you can use auto-completion, like control tab or tab, control space bar or tab, and then you see EE object is Kericho, and then again control tab, the zoom level, let's say 10, right? So that centers our map to that. Of course, you still don't see any map. Yeah, interesting, but you will see the map soon, because here we now don't have the base map automatically, but we can add it later. So again, we add layer whereby the Earth Engine object is Kericho, and then we can say we can add Kericho as we can directly add our elevation data instead of going to Kericho, adding Kericho layer border. So our elevation, we will clip it to our region of interest. So again, instead of eleve.clip, we use eleve $sign clip, right? And then we provide Kericho. After that, we need to provide the visualization parameters. That is, here they are called visparams, and visparams is a list. So again, here we just use the word list. In Python, we just used square brackets, okay? And we provide minimum value. Here we don't use colons, we just use semicolon, equal sign, and then a maximum of 2800, and then a palette. The 4 colors, those ones don't change, so we can directly bring them from here. These ones, copy, and then we provide the palette. Oh, but we don't provide a list like that in R. We provide them as a vector with C. So C, and then in bracket, each of them is provided differently. And then we can give it a name, and we say this is elevation Kericho or Kericho elevation, whichever, no problem at all. Okay, then we run that. So what are we seeing if we run that code? We see elevation map for Kericho, and it's on a base map. And this is now different from Google Earth Engine, different from JavaScript, which had this base map by default. Here, we are relying on another package called Leaflet to bring for us this base map, and then we can map or add our layers on top of it. All these analyses are not happening in R, they are all happening in the cloud under Google Earth Engine, because we have connected ourselves to the Google Earth Engine in the cloud, right? So we are enjoying the servers by Google. Thank you to them very much. Thank you. Okay, so let's again get statistics like we did before. So from eleve, we just say $sign instead of dot, and then we reduce region. Yeah, we reduce region, And again, here, if we provide a reducer, for example, enter, we can say reducer is equal to EE $, reducer $mean, right? So we want a reducer which is called mean. We want mean for which region? The geometry is Kericho, and then at what scale? At a scale of 30 meters, right? So that gives us, that achieves the same thing we were doing in Python and the same thing we were doing in JavaScript. So we can print start. It's a dictionary. You can see it's an Earth Engine dictionary. So we need to apply something like get info to extract the information from it. And then we see 1982.71. So basically the same mean elevation value within our region of interest that we obtained when we were using JavaScript, the same thing we got when we were using Python. Maybe the decimals are a bit different. This is 1982.89 here, 0.89 in R, 0.71. Some small differences, but 1982 is the same. So basically we are doing the same thing, but in 3 different languages. So from this, what is the main thing which I'm trying to pass around? Is that it doesn't matter which language you're using, you can still do all this geospatial analysis in the cloud, whether you're using JavaScript or Python or R. So do you need to learn JavaScript to do Google Earth Engine or geospatial analysis via Google Earth Engine? Generally, no. Do you need to learn Python? Generally, no. Do you need to learn R? Generally, no. Why? Pick the language of your choice among the 3 and learn it, and you will still be able to get the same thing. All right, so that was the main message I wanted to pass across today. Thank you for listening and enjoy coding with the language of your choice.